I'm Kevin Leone, and today I'm going to be going through the demo for our COMS4156 group project. We are the full-timers, and we are composed of John Galliano, Thomas Hook, Jonathan Conrad, myself, Kevin Leone, and Yue Sun. We have put together a machine learning algorithm service that will allow the users to upload and store custom datasets to the service, add, modify, or delete the existing datasets, share these datasets with other users of the service, as well as running specific machine learning algorithms on the datasets. We've implemented k-means, nearest neighbor, and linear regression as the algorithms, and they can all provide the different output types of either a list data or PNG output image. Our service is fully documented within our GitHub repository README file, where we have all of these steps to get up and running on localhost, as well as the commands needed to run to get up and running, and all of these steps to run and use our API client that we'll be using later on in our demo, so you'll see that in action. We also have documented here our continuous integration setup, which I'll go over in a minute, but also how to manually run each of the coverage, prospector, and unit test steps, as well as all of our Flask API endpoints, such as our sign-up and login endpoints that are used to authenticate, but also we have documented in here stuff for the database and running the algorithms. For the GitHub actions, we have different workflows that we have set up. I'll start by going through the Postman workflow, which goes through and runs the collection, and once it goes through and does that, it will upload all of those details output to the summary page, where we have the Postman test results, which we can download and look at. And we see 0 failed tests. We also have our analysis workflow, which goes through and runs our prospector PyTest coverage and then uploads those artifacts in a similar fashion, where we can download them and take a look at our prospector bugs.txt, PyTest output showing we passed all of our unit tests, as well as the coverage HTML, which shows a 93% coverage on the report. I'm going to go ahead and run the service right now on the left side, and then I'm going to start running the client over here. And for the first part that I'm going to do, I'm going to try and log in with a user that doesn't exist in the database, so new user, and we'll see that I'm going to try and put in the password, and it'll say it'll fail because the new user does not exist in the database user table. So I'm going to go ahead and run it again, but this time I'm going to sign up with new user. I'm going to create a password. And now that I'm in here, I can see all the available datasets that are in the SQLite database that we have. And that's done by using the list datasets, and you can see we have 4 available datasets. You can also go ahead and start up another instance of the client that will attach to the same service that's running. And I'm going to go ahead and just start by signing up and create that account, and you can see that this user can also only see those same 4 datasets, and that's because they are all public. Now, if I were on new user to create a new dataset, I can create a name for that. I'm going to say new data, and a path to the CSV file. We have one in our client folder right now, demo data.csv, and this will go ahead and upload that, and you have a couple options that you can add to the data that you're uploading. For example, I want to make this a private data set, so for this option I would choose no for do you want it to be public. So I'll choose no by typing N, and then at the current moment I'm not going to add any contributors, but you could add a list of contributors here, comma separated. So now if I were to list the data sets again, we can now see new data is available on the list for this new user account, but if I were to list it on new 2, you see that the new data set is not available because I made it private over here. If I were to add new 2 as a contributor to the new data set, so if I want to add new 2, I would just type in the contributor's username, hit enter, and now if we list the data sets on new 2, we'll see new data now pops up in there. Now if I were to then say I don't want new 2 to have access to that data set anymore, I can remove the contributor for that data set. Same process, type in the name, and we'll see now if we list the data, it's no longer available in new 2's list of data. We can also remove the the data set completely by using delete data set, and we just choose the option we want to delete, so I'll delete new data. And now when we list, we'll see it no longer exists in my available data sets. We can also go through and just retrieve data sets if we just want to take a look at what's available in that specific data set. So if I just want to look at what's in the demo dataset 2D, I can see the list output of that by using that retrieve data option. And then also we can go through and do run algorithms. We'll start by running the service on the left here. And I'm going to go ahead and run the client right here. I'm going to log in. In this case, I'm using the demo account. And I'll go ahead and use this run algorithm option to run through different algorithms. So I'm going to start with the k-means running on this scikit-learn example public dataset. I'm going to do a data type output, k-means. I'm going to choose the number of clusters. And we can see it creates the list type output with the different clusters and the data point associated with that cluster. Can also run that and produce an image. So the same thing, I'm just going to do an image, k-means. 3 is the number of clusters, and it's going to create this image, and the clusters are labeled and depicted here. You can also go ahead and run the nearest neighbor, and I'll do that on this demo 2D set. I'm going to do the data, nearest neighbor, and I'm going to choose the 3 closest neighbors. The implementation of nearest neighbor, I'm going to use auto, and the sample data point I will input as 1.3, 1.3. So this is going to find all the nearest neighbors to this specific data point. And as you can see, it creates the list type output where it labels the point as non-neighbor, neighbor, or the test point itself. And we can also run that and create an output image as well. Nearest neighbor, 3 neighbors, auto, 1.3, 1.3. And we have the output image where we have the non-neighbors, the neighbor points, and the test point. Can also run the linear regression algorithm. So for that, we're going to run that on this data set as well, create a data output, which is the list type, and we want to take the last column, the single last column, and use that as the training set. And as you can see, it'll output the coefficients and the intercept. So that can be used to create the actual line that's used to show the regression. And you can see that regression by using the image output for linear regression, and you can see all the data points and then the line that uses that coefficient and intercept to be created.